All right, so again, district assessment tomorrow, extra help isn't here today at lunch, and if we have too many people, we'll spill across the hall to the Sadler's room in 109. I have all of the old and current calculus students on deck to come in and help. I wrote all the rec letters. I will rescind the letters if they don't come and help. All right. And there's TAP after school if you're not able to make it at lunch. And you can come in the morning tomorrow also, but I can't help at lunch because the test will have already been out, so I can't help then. So lunch today, after school today, in the F wing, or in here tomorrow morning. So we gave you this over the long weekend. Yes, Noah?
If we're coming in the morning, around what time?
I will not like to see students before 7, but after that's okay. I'll have had some caffeine by then. But if you come before 7, I will just be mean.
Okay. Are you here before 7?
I am here before 7 every day.
Gosh.
I know, it's ridiculous. Okay, so when we were doing this unit, we said things that were y equals x to the a if a was bigger than what number? There were 3 things. If it's bigger than 1, what kind of function is it going to look like? Y equals x squared. Yeah, Holiday just drew this in the air. So in quadrant 1, it's going to look like that. Is this first exponent bigger than 1? No. Second exponent bigger than 1? Yes. Okay, so quadrant 1 is going to look like that. All right, what was the other region you were supposed to check?
In between 0 and 1.
So if the a value was between 0 and 1, what function was it going to look like? That we let, what?
Square root.
Square root. Which square root looks like that in quadrant 1. Okay, this guy, between 0 and 1, or bigger than 1, between 0 and 1, or the other case? Between them. So, all right, in quadrant 1, this one's going to look like that. And then the other case, the last case was if a is less than 0. Okay, so, and that's going to look like 1 over x, which looks like that. And I don't have any negatives here. Sorry, so I should have gone to this one. Bigger than 1, between 0 and 1, or negative? 3 over 2?
Bigger than
Bigger than 1. All right. And this first column, or this thing here where I'm asking you to check -1, that's to see if it's got a tail. So Ella, when I put in -1 here, it's -1 squared and then to the 1/3. What is -1 squared?
Just 1.
Positive 1. -1 times -1 squishes together to become positive. And then the third root of positive 1 is a 1. So this guy is going to have a tail and it's going to go up. So with that quick sketch, you should be able to say all the things. So Beckham, what is the domain of this function? All the numbers. Jasper, looking at this quick sketch, the range, what are all the y values?
0 to infinity.
Square bracket on 0 or round?
Round.
Square. It hits the 0. So square bracket 0 to infinity. Cameron, left end behavior.
0.
Left end, where is at the end of time where
Infinity.
positive infinity? Lucia, even, odd, or neither?
Even.
Even. She didn't say it with a lot of confidence. Why is it even? Visually, what happens? Noah?
There's nothing in the other options that give us
Okay, folds over the
a y.
y-axis. Right? Remember these? Okay, this one. What is -1 times itself 5 times? -1, yes. Joaquin, -1 to the 1/3. Is something times itself 3 times -1?
Yeah.
What?
-1.
Okay, so this one exists, it's got a tail and it's gonna go down. Tim, domain,
Negative infinity, infinity.
Mayuna, range? What Y values come out? The same thing, negative infinity to positive infinity. All the numbers are represented. Alicia, left end behavior. As x goes to negative infinity, what's y doing? Also going to negative infinity. Leah, even, odd, or neither? Odd, because what did you look at? If you can spin it over the origin and see the same thing, it's odd. Okay. Natalie, -1 times itself 3 times.
Undefined.
Okay, you're giving me the end answer. So -1 times -1 times -1 is -1, but then she says that to the half, it's undefined. You can't do the square root of -1. So that one, no tail. So Kevin, what does that make the domain of this last guy?
0, infinity,
0 to infinity. Round or square bracket on the 0?
square.
Square. Fakir, range? Square or round on the 0? Square. Jean Gideon, left end behavior.
None.
Don't have one. There is no left end at negative infinity. It's not the left end of the picture, it's the left end of the whole graph, the end of time or beginning of time. Naomi, even, odd, neither? Neither. Doesn't fold, doesn't spin. Any of this familiar? Most of you did pretty well on this exit card, but it's now old. But all you need to remember are these things. Is the exponent bigger than 1, between 0 and 1, or is it negative? So then, does it behave like x squared, square root, or 1 over x? And then test that -1 to see, does it have a tail, does it have a tail, sad tail, or no tail? I want to do just one of these negatives. As you pick one. The f of x, g of x, or h of x? G of x. Okay. It's negative, so we're going to do that. Now we need to test the other side. -1 times itself 5 times. Charles, -1 times itself 5 times is still negative. An odd number of them, it's still negative. That -1 to the 1/3 power, still -1. So it's going to have a tail, well, sort of a tail. It's going to have something down there. Allie, what's the domain of this one? This one's the yucky one.
I said negative infinity, positive infinity.
I can't put in every number. There's a break at one place. What value, writing this as a positive exponent, when is the denominator going to be 0?
0.
When x is 0. So I need to throw that one out. I'm not allowed to divide by 0. So domain is everybody except 0. Ashley, looking at the range, what are all the possible y values? And, okay, so this one, we get exactly the same thing. All the y values bubbling up from negative infinity to 0, then it cuts and picks up immediately on the other side. Joaquin, left-hand behavior.
Negative infinity.
When x is negative infinity, what's the y value appear to be doing?
Oh, 0.
0. There you go. So guys, draw a picture. It helps. Emmy, even, odd, or neither?
Odd.
Odd, because we can spin it around the origin. Okay? And that's what the others look like. Any questions on power functions? I'd like to get to, yeah.
Wait, for J, -1, are you writing it out? Wait, can I show you this? Like, is this what you're doing? Or wait, what are you writing? Asking.
Okay,
That, or
okay.
is it-
First of all, Algebra 2, they spent a lot of time making you guys pull these apart to look like that. Moving on, like into calculus, I hate that. Like, it's not helpful to you. It's more of a challenge. But, so, x to the a over b can be written as x to the a, then raised to the 1 over b, or it can be x to the 1 over b, then raised to the a. What do I mean? Um, 8 to the 2/3. I could do 8 squared, which is 64. And 64, what times itself 3 times is 64? Does anybody know?
4.
4. So that's the hard way to do this one. I could have done 8 to the 1/3 and then squaring. What times itself 3 times makes 8?
2.
2. And then what is 2 squared? It is also 4. So Cameron, it depends on what kind of problem you're doing. We can either do the top thing, do 8 squared and then do the cube root, or we can do the bottom thing and do the cube root then squared.
It's just like whatever's easier.
Yeah, I mean, so in this case, I made the number big, which is hard. But for these guys, -1 to the 3 is -1 times -1 times -1, which is just -1, but then square root of -1 doesn't exist. So depends on what you're doing, which is easier to pull apart.
Okay.
Personal preference. Yes, ma'am?
If you're looking at the equation, how do you know which bracket refers to that domain?
Looking at the equation, how do you tell what the domain is? Personally, I have to draw the quick sketch. So all of them were negative exponents, so all of them are going to do this in quadrant 1. And then here, testing -1 to those odd powers, a -1 is going to come back out, which means it's going to have that coordinate down here. So here, what I was just talking about with Cameron, -1 to the 4th, -1 times itself 4 times became positive. And +1 to the 1/5 is still positive. So it's going to have a tail, but it's going to be over there.
But how do you know which bracket?
How do we know if it's square or round?
Yeah.
Okay. All of these in the domain, it doesn't get to 0. I'm not allowed to divide by 0, so that one isn't happening. And so those guys make asymptotes. There's a vertical asymptote at x equals 0. There's a horizontal asymptote at y equals 0. Kind of there just is. You need to know what the graph looks like. Yes?
How come for in the f of x, if the range is just 0, infinity, how come it's not like the other one?
Okay, looking at it, the y values were up here. Do they ever go negative? No. Why do they not go negative? Because I did to the 4th power, negative times negative, even number of them, the negatives became positive, so I can never get a negative y value, so it's just 0 and bigger. And you wanna portable sunshade. Oh, sorry. You just push back. Other questions on this stuff? So this flip chart is posted and the answer key to the review packet is posted as well. Yeah, oh, thought that was a question. Nope. All right. Let's look at number 2. So these are kind of like the things that were on the quiz. Beckham, what's the first thing I gotta do to find the domain? Gotta factor it, okay. Anyone factor this for me? Tim?
For the numerator or denominator, or?
Your choice, or actually, which one do I need to look at for the domain, or do I need to look at both?
Look at both.
For domain, I only need the denominator, but I'm gonna have to do the top anyway. But, all right, factor for me, what do I get?
We're doing number 2?
Yes, skipping this one for now.
You get 5, parentheses, x plus 3.
And down
X plus
below?
3, x
Okay.
plus 3, x minus 3.
All right, so those of you shaky with the factoring, looking up top, is there anything that comes out of both pieces? A 5 comes out of both, no x's come out of both, so taking the 5 out, by taking out, I mean he's dividing. 5x divided by 5, left x. 15 divided by 5, left 3. It was a plus, it stays a plus. This is difference of squares. This is a perfect square, that's a perfect square. So square root of that first term, square root of x squared is x. So we're going to do an x in the first place and an x in the first place. 9, square root of 9 is 3. It's the second guy, so I'm going to put that in both ones. And Tim said plus, minus. So Jasper, what x values do I need to kick out of the domain?
3.
And? And -3. So how did he get those? Where does this term equal 0 and where does that term equal 0? At positive and -3, so the domain is everybody except those guys. Nathan, how do I find holes?
You look for a common term on both the top and bottom of the fraction.
Do I have any?
Yeah, x plus 3. And then you just turn it into 5 over x minus 3, and you substitute x for positive 3.
Okay, Joaquin, what is the x value where the hole's going to happen?
I mean, negative 3.
It would be -3, right? It would be 5 over -3 minus 3.
So the x value where the hole's going to be is where that matching factor is 0. So -3, and Holiday, I wasn't listening to them close enough because I was writing too many other things. How do I find the y value?
You plug the x value into the rest of the thing.
Okay, so you look at the leftovers. The leftovers are the stuff in green. So, Fakir, when I plug in -3 to the leftovers, what do I get? 5 over, plugging this in for x. Plugging -3 in for x, I get -5 over 6. Okay, so factor it first. Remove like all the things from the domain. Everybody that was in the bottom that could have made a divide by 0, kick them out of the domain. Then reduce it. Now we're only going to work with the leftovers. Vertical asymptotes are the things that are still there. So Naomi, what vertical asymptotes do I have, if any?
30.
As the equation of a line?
X equals 3.
Thank you. X equals 3. Kevin, looking at the leftovers, top heavy, bottom heavy equal.
It's up and
Bottom heavy.
bottom.
So, because there's an X to the first and the bottom, there's no X's on the top. So
Yeah.
it's bottom heavy, so it's gonna be Y equals what?
0.
0. Do I have a slant asymptote? Joaquin's shaking his head, Naomi's shaking her head,
No.
Arden's shaking her head. No. Why no?
It's not top.
Bailey?
Isn't it because if you have a horizontal asymptote, you can't have a
If you've got a horizontal, you cannot have a slant. If you have a slant, you cannot have a horizontal. And Gene Gideon said, if it's top heavy, it's gonna be a slant and you have no horizontal. So like, this is not top heavy, so there is not a slant. Bailey said, if you got a horizontal, you can't have a slant. Both, yes, yes. Okay. I'm gonna skip the end behaviors till I graph it. Or can I do that right now? Jonathan says I can do it right now. What is it right now? So left and right end behavior, why do you know it's 0? Because what horizontal asymptote means is, what is the end behavior? So left and right end behavior, it's gonna go to wherever that horizontal asymptote is. X-intercepts. How do I find x-intercepts? Samara, got any idea?
You use the denominator from what's left of the denominator, so it would be -3, 0.
Okay. X-intercept is where does it hit this axis? That's when the y value is going to be 0. So I'm going to take all the leftovers and set it to 0. When I cross multiply, what is 0 oops. What is 0 times x minus 3? 0 times anything. 0. And what is 5 times 1?
5.
So when does 0 equal 5? It doesn't. So when does it cross the x-axis? Doesn't. LL y-intercept, how do I find that? It's when we hit this axis.
You set x equals 0.
You set x to equal to 0. So when x is 0, looking at the leftovers, I get that. 0 and -5/3. Yes? X-intercept, x. When does it cross this axis? When y is 0. So right here, I took my leftovers, this 5 over x minus 3, and I set it to 0. And then I cross multiplied. There isn't a 1 written here, but if I tell you the number is 5, it's 5 over 1. Well, this is 0, it's 0 over 1. Cross multiply. 5 times 1 is 5, and Samara said 0 times stuff is going to be 0. When does 5 equal 0? It doesn't. And then Ella said, for the y thing, she said plug in 0 for x here. So the coordinate where it's going to hit this axis, x had to be 0, and the y value is -5 over 3. Kevin, then Tessa. Kevin?
So to find the x-intercept, basically like if the top isn't like x minus 3 or x squared.
If the top has no x's in it, you ain't got no nothing.
Yeah.
Yep. Tessa?
That's just go ahead.
Yep, that's it. Tessa?
How did you get the y value of the whole?
How did we get the y value of the whole? I don't remember who told me, somebody over here. Said take the leftovers and the x value of the whole and put that x value in. So here's, do you know how to find the x value of the whole? Setting that duplicated factor to 0. We got -3 right here. And plug that x value into the leftovers and we get -5 over 6. Okay, so graphing, you're gonna have to be able to graph. With all this information that we just found, without using a calculator, I'm gonna plot the line x equals 3. It's an asymptote. X equals 3. And I'm gonna plot the horizontal asymptote, y equals 0. Graph, graph. I'm gonna put the hole on there. -3, so 1, 2, 3, and then -5/6. Okay, that's a little gross. It's a little bit bigger than -1. And then the y-intercept, 0 and -5/3. -5/3. Bigger than -1, less than -1. Less, okay. Bigger than -2 or less than -2? Oh, it says less, so it's like between -1 and 2. And you see how tiny these things are? Just get close, you know? Is it gonna be colored in or is it gonna be a hole? Charles, what do you think? Colored in or the y-intercept?
Just colored.
Colored in. Okay, and that's all the information I have. And I would like you guys to get 3 coordinates on each side of the asymptote. Do I have 3 coordinates to the left? No. Emmy's saying no. Jean Gideon, what's a good x value to choose on the left side of that asymptote?
Would
1?
+1?
+1, perfect. And am I gonna plug it into the original equation or the slim trim reduced thing?
The reduced.
The reduced thing, because it's just smaller numbers. So putting in 1, 5 over 1 minus 3. What is 1 minus 3? -2. So when x is 1, -5 over 2. Then connect the dots. Don't make them like straight and chunky. Goes towards the asymptotes in a smooth curve. And is that all there is to it, or is there another side?
Another side.
There's another side. Kevin, what were you gonna say?
How much time are we gonna have for rational function on the district assessment?
I mean,
Like, would it be like 5 questions in like 10 minutes each? For like.
the text is meant to be like 20 or 30 minutes and to give you more time. Like, so you'll have the entire class period to do it.
So how many questions really is?
There's like 5 questions on the test.
So 6-minute timers basically to practice it?
You'll see tomorrow, but like, they're not gonna make you graph a whole bunch of these. They might ask you about the properties, but they're not gonna ask you to graph a whole bunch. Okay, I need 3 coordinates on the other side. Lucia, what are good x values to choose? Okay, where is the horizontal asymptote?
Can you do 4?
4. And I need 3 of them.
Oh, do 5, 6.
Yeah, sure. So the asymptote was at 3, so what are good numbers to pick on that side? How about 4, 5, and 6? Perfect. What are we plugging it into? This. So putting 4 in for x, Bailey, what do I get when I do 5 over 4 minus 3? 5 over 1. So I'm gonna plot the coordinate 4, 1, 2, 3, 4, 5. And it's a solid dot, it's gonna hit that one. Tessa, plugging in 5, what do I get?
You get
2.5 or 5 over 2? Plugging in 6, Allie, what do I get?
5 over 3.
5 over 3. And then connect the dots with a smooth curve, and it goes towards the asymptotes, and that's it. Fully drawn, like the asymptotes are there, the hole is there, the x-intercepts didn't have any, y-intercept is ground, and then I found accurate coordinates on each side, plotted them, and there you go. Good? Like, if you can do this, you will do well on tomorrow's exit card, or sorry, exit card, district assessment. How do you feel? Spectacular, I see. All right. Can you guys try number 3? If you haven't done it, do it now. If you did, compare your answers with your neighbors. Yes.
Why do I lose points for this? Instead of X, so like, why do I lose points? Zero. I must have been one. I didn't. You just said y-intercept. So dumb. So why do they have it when all it's almost yeah, it's like in 4 times. Honestly, I don't know how to do it. Maybe I'll find out.
Yeah, they all show up at the same. You didn't know that? Hey, and Evan, she did the one thing. She's really close. Best friends. That's why they all hate me. So it's not really hard to things. Sticker and everything. I have a sticker.
Is it 0? I was like,
Okay, and remember, you need to turn in quiz corrections if you would like to do a retake. Many of you did not turn in corrections for the first 2 quizzes that were out there. If you got under an 80%, you are required to do the corrections. If you would like to do a retake, you are required to do the corrections. If you did not get a B or better on this quiz, you need to do corrections. It is in your best interest to come in at lunch today. And we can get your corrections done, and you can get extra studying for the district assessment that is tomorrow that will be on things like this. Yes? Corrections are technically due on Thursday, 2 days after you get that quiz back. You got it back today, due in 2 days. But like, there will be a lot of people here to help today, so it's a good idea to do it today, and it's, your district assessment is on it tomorrow. Can anyone factor this for us, like come up to the board and factor? Can you get in? Yeah? Okay.
Number 3.
Yeah. Come up and do it.
Okay.
I just like, yeah, tap out all day. Yes.
This is not personal, but like on the actual like, district assessment, is this like all gonna be on there? Or do you remember what those other ones we did where they're like
Piecewise stuff?
yeah, is that on there?
There's, I don't know.
Yeah, I forgot you don't make it, yeah.
Yeah, not right.
But is
But
this
it's,
given by them?
this is by the county.
Okay, so like it should be like this?
It's a lot of rational, graphing rational functions and understanding properties. I don't believe there's much, if any, piecewise.
Okay, thank you.
Yes.
Wait, what is this, like, minus 3?
Because you didn't find a signed asymptote. Like you showed no calculation of it at all.
Oh,
So if all that space was for you to do the polynomial long division behind the slant. And you found lots of other things, but not that. Okay, do we agree with their factoring?
Yeah.
Jim Gideon pulled a 3x out of the numerator, out of both pieces, and was left with an x plus 4. And then he factored the bottom, which, if you can factor the top by taking that greatest common factor out, it's a hint. There's an x plus 4. Look to see, like if you don't know how to factor, look to see if you took a x and a plus 4, what does that make the other one have to be? Like, it's possible that it's a good guide. Okay, so like I said on the first one, do the domain first. So, questions, guys?
I'm just clarifying her about how I got the horizontal asymptote.
Okay.
Because it's with the exponent with the degree, right?
Okay, so like for this one, the horizontal asymptote, do we have one or not?
Yeah, we do.
Yes, we do. Is it gonna be a y equals 0 or y equals something else? Y equals something else, because the highest exponent in here anywhere is that x squared. So they're equal, and as Bailey said right away, because there's a horizontal, there ain't no slant. I'm gonna write none in there right away. Y equals what? 3, because we take the coefficients in front of those x squareds. So it's y equals 3. I could write 3 over 1, I don't have to. Ashley, looking at the denominator that's factored here, what numbers do I need to throw out of the domain? So, perfect. So she said -4 and +2. How did she get those numbers? Where does this factor equal 0? Where does that factor equal 0? And then you gotta be careful in how you stuff them in the domain. -infinity to 2 or -infinity to -4?
-4.
The -4, the lower number first. It's gotta be in order, because if you change the order, you've just, created a problem. Okay. Chloe, do I have a hole in this equation or not?
Yeah.
At what x value?
4. Because the crux, yeah.
-4. Why is it -4, not +4? Because Noah just said when we set it to 0 and solve, x is -4 is the problem. And Bailey, do you know what we plug this into to get the y value? The leftovers. So when I plug in -4 here, I get -12 over 8. Or I could have just reduced this up front and gotten -3 over 2. Vertical asymptotes from what's left over. Guys, the bell did not ring. So again, Answers are posted. There is an optional delta math. It's a huge delta math with, hey, you wanted to work on horizontal asymptotes, you wanted to work on finding holes, you wanted to work on whatever. There's titles to them. You can pick and choose what you need to do. Yes, Sophia? Yep. And when the zero reacts,
Nate.
the zero will hit the axis. And see right here, it does hit the origin.